So hello everyone, once again welcome to my YouTube channel and the lecture series of the signal processing. So we are today going to discuss the most important part, basic fundamentals, that is the elementary continuous time signal. And in this signal, first we start with the most important signal or function, that is the direct delta function, that is not function but a distribution, or it is also known as the impulse signal, or you can say the function, impulse function, right? So you can define the direct delta function. The direct delta can be loosely thought, it can be loosely thought as a function, it can be loosely thought as a function on the real line, which is zero everywhere, which is zero everywhere except at the origin, except at the origin. What it mean? It mean mathematically, where at the origin it is where it is infinite, where it is, it is infinite, infinite. So it means delta, it is represented by the delta t, direct delta function represented by delta t. So it is given, it is defined at t equal to 0. Okay, at the origin the value is infinite, otherwise the value is 0. Every elsewhere it is a 0. So the concept of, what is the concept? How it is defined? So it is nothing. It is a it is not a function. Okay, and remember how it, what is the concept of the impulse signal? Let us. I will explain in a moment. So which is, and also it is defined, which is also constant, which is a constant here to satisfy the identity, and the identity is very important. The area under this region is minus infinity to infinity delta t dt is equal to the 1, is equal to the 1. Very important, very important. So what it mean? It mean we have a area, let's say we have a area, this is the, let's say, minus t by 2 to t by 2, and the magnitude, let's say, the 1 by t. So the 1 by t, how the pen will be going to color the change. Okay, I don't how the, okay, no, this is the setting, I think. Okay, export image. Okay, so let's say we have the minus t by 2. Okay, and let's say uh, now after some constant we are going to decrease this distance. Okay, with and the area of this the area of this cover area minus t by 2 to t by 2 and 1 by t is, the area is very obvious, is 1. Okay, so after the reducing this length minus t by 2 approaching towards the origin, and some from t by 2 also approaching towards origin. Okay, and it is reduces, and the area will remain same. It means we have to increase the height, or you can magnitude, and the area again will remain, the same. This area is 1. Okay, again we are going to increase the height and reducing the the width, so that the area remain 1. Okay, so this is the now condition. So imagine one condition where the minus t, this t tending towards 0, this t tending towards 0 origin, okay, tending towards 0, and you have to keep the this constant 1, area 1. So what we have to do, we we have to think, we have to thought about the value at the origin to infinite. Okay, so in this case, the delta t, when the delta t tends to 0, then delta t becomes, the delta t tends to infinite. For for keeping this constant minus infinity to infinity dt equals to 1. So this scenario, this is the distribution, and this distribution is represented in this mathematical form. This mathematical form, okay, this mathematical form, delta t tends to infinite, okay, and delta t tends equal to 0, the value is infinite, and for the elsewhere it is the 0. So this concept is, this is the merely a heuristic approximation characterization. It is the heuristic characterization, heuristic characterization, or you can say the approximation. Okay, the direct delta is not a function in traditional case, traditional sense. It is not a function. Okay, why? Because this function, no function defined on the real number has this property. Because this is the value is infinite. This is not defined on the real time, real number. Okay, so direct delta function can be rigorously defined. Rigorously, you can say rigorously defined either as a distribution, either as a distribution or as a measure. It is very, very important, right? Distribution or a measure. So the first concept of this delta function, the source where you can take the source of the delta function is, you can take from the Paul Dirac. It is given by the Paul Dirac. He is proposed in the book Principles of Quantum Mechanics. You can more explore the Dirac function in this book, published in 1930. The concept, simple concept, the Paul Dirac, the distribution concept is based on the physical model that visualize a delta function is a mass distribution, is a mass distribution of finite finite total mass m. Okay, the integer over the mass distribution, right? The integer over the mass distribution. So what happened when the distribution becomes a smaller? When you can say the distribution, mass distribution become a smaller and a smaller, a smaller and a smaller, right? A smaller and a smaller, while you can say the m is constant. You have to keep the m constant, and distribution becomes smaller and smaller. Then it means mass is going to shrink. Mass is going to shrink. Mass distribution shrinks to a point mass, of value m. Okay, so which may be definition has zero extent. At the zero value, at the zero size, the mass m is the value of mass is very, very high. The point at that point, the value is very high, m. Okay, so it means with the limit point of mass, the distribution becomes a direct delta function. Remember, in the limit point of mass, in the limit point of the mass, in the limit point of the mass, the distribution becomes direct delta, direct delta function. Okay. So the next question is the derivative of delta function. So the derivative of delta function, this question has been asked the GATE exam. If a direct delta function is a distribution, direct delta function is nothing but the direct delta function is distribution. It is not function, as I all told. So it means the derivative of direct delta function direct delta function is not surprisingly not surprisingly the derivative is the derivative is also a distribution is also a distribution. So what it mean? It mean whenever you ask what is the direct delta function, so simple, you can say the double direct delta function. Double direct delta function is the derivative of the first direct delta function. Okay, direct function. This is the derivative d by dt of the direct delta function del t. Okay, so next is the unit impulse function. So mathematically, for the convenience, for the sake of the mathematics, it is defined as a unit impulse function. A unit impulse function. Unit impulse function means in a very short time. In a very short time, the value is very high, and since the amplitude is unit, so it is given as delta t is equals to 1 for t at t equal to 0. Otherwise, t is not equal to 0. The value is 0. Simple. So as simple as that. This is the value is 1. Okay, and this is the delta t. Okay. So, and also remember, minus infinity to infinity, this value xpt dt is equals to 1. Okay, what is the xpt dt? So this is the minus tau by 2 to tau by 2. Okay, and value is 1 by tau, and this function is xpt. Okay, so as tau tends to 0, the value is changing towards the value 1. Okay, so this is the delta t function. Okay, so as tau tends to 0, the height get progressively higher, and the width of the pulse gets successively narrower as shown. So in the limit, we have the pulse which has a infinite height and 0 width, yet the area is still remain 1. Okay, so in the unit impulse function, for convenience, this delta t is defined at t equal to 0, 1, otherwise it is the infinite. Simple. Okay, so the next lecture we will discuss the step function. So thank you.